Welcome, and thank you for attending today's Enterprise Tech Journal hosted webinar. This is Denny Yost with Enterprise Systems Media and your host for today's webinar. To send us a question during the webinar, please click on the chat bubble icon on the left side of your screen. That will open the chat window, which in this case is only being used to send us your questions. While we probably will not be able to answer all of the questions in the allotted time of this webinar, we will be emailing answers to the questions to all attendees within a week after the webinar. Joining us today from Logon Software is Mark Shora. Mark will be telling us a little about Logon Software and the many benefits of using Logon VTFM NewGen, a software-only solution bringing mainframe reliability and availability to your tape management operations that leverages on and off-prem cloud object storage as well as other storage types while seamlessly integrating with your existing tape management software. At this time, I will turn the floor over to Mark.
Hello everyone, and thank you for joining this presentation on Logon VTFM NewGen and the value it provides to organizations looking to evolve their tape strategy. This presentation was developed by Sharon Chen, CTO and Development Manager for VTFM. Before we start, just a word about Logon Software for those who don't know us. Logon has been in business for over 40 years and employs over 1,000 individuals worldwide. We're both a consultancy as well as a software development house focusing on innovative solutions for the mainframe. For those of you who are interested in learning more, please visit us at logon.com. During the presentation, you'll have the opportunity to enter questions into the chat window. For sake of continuity, I'll answer these at the end of the presentation. Let's proceed. We'll start with a high-level overview of the product's technology. Then we'll discuss a use case, how you can migrate your backups from your current VTS, VTL, or ATL hardware solution to cloud object storage utilizing VTFM NewGen. We'll talk about the virtual tape processing that we do. We'll talk about VTFM's multi-tier storage options, including virtual tape eVaults and immutable backups on air-gap storage. We'll discuss VTM's cloud data storage option, a feature that complements VTFM's virtual tape capability with the ability to copy any ZOS dataset to cloud object storage. We'll talk about storage usage and how to recover from a disaster utilizing VTFM NewGen's technology. Then we'll examine a use case involving a customer's VTFM configuration that utilizes this recovery capability. Lastly, we'll conclude the presentation with a summary of VTFM's value proposition. At the end of the presentation, there will be time for questions. Let's start with an introduction to the product. First and foremost, VTFM is a software-only solution that leverages ZOS facilities to emulate virtual tape controllers and tape devices in ZOS memory constructs, then writing the tape data to tape dataset containers or cloud object storage. The emulated tape media is stored on targets including on-prem or off-prem cloud object storage or local FICON attached DASD by association of the chosen storage locations with tape pools defined by you. Users can assign virtual tapes to pools via tape pool rules using selection criteria such as job name, DSN, and program name, providing maximum flexibility for virtual tape residency. For example, frequently accessed virtual tapes might be stored on FICON attached DASD, while virtual tapes with very low access can be stored on inexpensive archive class cloud object storage. VTFM runs primarily on ZIP, so the cost of processing is low. VTFM is a powerful complement or replacement for any type of tape library, including hardware-based virtual tape libraries, physical tape libraries, and robotic solutions. Best of all, no JCL changes are required to implement. VTFM is a plug-and-play solution. VTFM is fully transparent to all storage managers, including HSM, ABR, and DMS-CA disk. They all see and treat VTFM tape drives just as they do any other tape drive. VTFM supports all industry standard tape management products, including CA1, Control-T, TLMS, and RMM. VTFM offers unique e-vaulting technology to move virtual tapes from your main site to various remote e-vaults, including other sites running VTFM. When a tape is e-vaulted to another ZOS running VTFM, it is immediately available to be mounted as a local tape. You can e-vault your tapes to any FTP server for safekeeping, or you can e-vault your virtual tapes to cloud object storage to be stored there as immutable air-gapped objects. Of course, any tape moved to an e-vault can be automatically recalled to the main site when needed to satisfy a mount request. If desired, you can drop the use of DASD completely in favor of cloud residency for all your virtual tapes. Any mix of on-prem and off-prem cloud object storage is allowed. But not just virtual tapes. VTFM also provides a technology to copy any ZOS dataset to cloud object storage. The request may be initiated through ISPF panels or batch jobs. This is our Cloud Data Storage Facility, or CDS for short. Up to 999 versions of the same dataset can be stored with expiration dates. All expirations are managed in the cloud so that dataset copies do not need to be recalled from the cloud to be expired. So with VTFM, you get a single product to handle both virtual tapes and CDS. VTFM is the ultimate tool to migrate from your hardware-based virtual tapes to software-driven virtual tape storage in the cloud. First, let's talk about active migration of your existing VTS tapes to the cloud. All you need to do is install VTFM, and from that point forward, utilize the HSM recycle command for HSM tapes, or tape copy software to copy non-HSM tapes to the cloud object storage of your choosing. This is done by setting the target DD to point to the virtual tape media managed by VTFM. This can be done explicitly using the VTFM unit, or it can be done via dynamic reallocation rules. From this point forward, the tape pool rule will associate the virtual tape with the tape pool linked to the disk pool that points to your cloud object storage. Again, your cloud object storage may be on-prem or off-prem. To migrate newly created tapes, run your regular tape workload as you normally do, or just point the DD that defines output tapes to the new VTFM virtual tape. Again, you can do this through our dynamic reallocation policies, or you can explicitly point the DD to VTFM unit. Just keep running the HSM recycle tape copy jobs for non-HSM tapes in the background at a low priority, and after some period of time, the migration of your old VTS tapes to VTFM tapes in the cloud will be complete. That's it. Let's discuss VTM's value proposition. VTFM lets you get rid of expensive tape hardware by moving data to the cloud. Procurement, maintenance, and utility costs go down for both your main and disaster recovery sites. Think of us as a broom that clears your floor of all these tape libraries. VTFM also offers PAT, Parallel Access Tape. PAT allows for multiple simultaneous reads of a specific tape. This is unprecedented in ZOS, where sharing tapes is not allowed due to the original nature of the physical tape device. This ZOS restriction remains today and applies to virtual as well as physical tapes. VTFM cleverly eliminates this restriction. PAT dramatically reduces the time required to restore multiple data sets stacked on single tapes. Likewise, if you need to repeatedly access the same tape for various non-sequential data processing jobs, you can run all these jobs concurrently as opposed to running them one after the other. By virtue of VTFM's intelligent I/O, VTFM can shorten the batch window, the backup window, and most importantly, recovery time. Applications see faster I/O completion because VTFM handles I/O in memory where it reblocks it to maximize throughput to the cloud and to local disk pools. VTFM reduces the number of EXCPs, or physical I/Os, that are executed for any given virtual tape. VTFM delivers this performance advantage to all z/OS users. DB2, for example, benefits when writing archive logs and backup tables to tape. Here again, parallel access tape delivers value. When restoring tables from stack tapes, all tables in a tape can be restored concurrently. VTFM delivers all the above utilizing the standard z/OS subsystem architecture. Fast FICON or OSA cards in standard DASD or on or off-prem cloud object storage. The VTFM tape library, by the way, may be accessed across LPARs and even beyond the scope of a parallel sysplex when sharing virtual tapes with authorized users. So continuing to look at the value proposition, VTFM offers several storage classes to store your virtual tapes. Storage can be FICON connected DASD, where you enjoy the advantage of getting the first block of data immediately upon open, or you can use cloud object storage, including on or off-prem S3 and S3 compatible storage or Azure cloud storage. Moreover, you can eVault any tape to target eVault types, including other z/OS systems running VTFM, any standard FTP server, or any supported cloud object storage. We'll go over these options in detail later in the presentation. Think of us as a channel for piping tapes from their current residents on any tape library you may have over to the cloud like so. Relocating tapes to the cloud by copying existing tape images or just the tape datasets. It's your choice. We'll create new tapes directly in cloud storage without any changes to JCL. Simply define policies for VTFM NewGen, and we'll take care of dynamically reallocating those tapes, DDs, to VTFM virtual tape units. VTFM also offers the ability to copy z/OS datasets to the cloud for safekeeping via our cloud data storage or CDS feature. Datasets can be copied to the cloud with or without z/OS metadata. When copied with metadata, they can be recalled to z/OS for processing. When copied without metadata, the datasets are written as flat binary object files that include only the user data. This is a one-way option that is useful if you want to migrate applications to the cloud and you need to read the associated data directly from co-located datasets. The open system application needs to know the internal record structure of the CDS file and perform the IPSIDIC to ASCII conversion. VTFM offers multi-tier storage that is enabled by a few technologies. The first approach takes advantage of tape management vault cycles that tell VTFM which tape from which tape pool to move to an eVault. These tape pool definitions should be set by the user according to tape management tape pool names. Another option makes use of VTFM's internal tape pool capability. This native capability provides additional useful functionality. Both options are supported. VTFM may, for example, set a specific eVault behavior for a tape pool, such that tapes from this tape pool, upon unload from the virtual tape drive, will be eVaulted automatically to an eVault location associated with that tape pool. This is accomplished using VTFM's internal tape pool capabilities as opposed to your external tape management solution's eVault cycles. Regardless of the tape workload, you may tell VTFM to ad hoc copy z/OS datasets to the cloud and maintain up to 999 versions of each. VTFM manages the expiration dates for these files in such a way that CDS file does not have to be recalled to z/OS in order to expire it. A tape pool's storage utilization may be managed by moving tapes away from the tape pool to an eVault location of your choice, be it the cloud, an FTP server, or another instance of VTFM in a different z/OS. This can be done automatically by setting a space utilization threshold for the tape pool and running a VTFM mount prediction program that determines which tapes are less likely to be mounted, and then preferentially eVaulting these tapes in order to meet the space utilization threshold setting. This is all done automatically through policy settings. Or you can simply select a tape manually to be moved from the tape pool to an external eVault location. Let's talk about multi-tier protection with VTFM. Tier 1 storage, of course, contains your source ZOS dataset stored in local ZOS Vicon connected DASD. We protect the data by utilizing a multi-tier approach. Tier 2 contains VTFM virtual tape stored locally, perhaps utilizing on-prem cloud object storage, perhaps Vicon connected DASD. Tier 3 storage contains those virtual tapes stored off-site, perhaps on off-prem cloud object storage, a remote FTP server, or another ZOS running VTFM. Tier 3 storage is targeted via VTFM's unique e-vaulting technology, used to move tapes electronically from our local VTFM virtual tape library to one or more e-vault locations. With VTFM, copying datasets to the cloud doesn't require that they be written to VTFM virtual tape. That's an option. You also have the option of copying any type of ZOS dataset, QSAM, PDS, or even VSAM or LDS directly to the cloud without writing it to tape utilizing CDS. CDS can copy datasets from ZOS directly to the cloud and recall them back as needed. VTFM e-vaulting can target 3 different storage types. With eVault Type 3, VTFM can move virtual tape images from the VTFM main library to any standard FTP server anywhere in the world as defined within VTFM by site addresses and credentials. With eVault Type 4, VTFM will forward tapes from your main site to another ZOS site running VTFM, most likely your disaster recovery site. The remote VTFM will receive the tapes into its own library, making them immediately available for a mount in the event of a disaster. With eVault Type 6, VTFM stores virtual tapes in the cloud for safekeeping, utilizing storage options that provide for immutability and air-gap protection. This is a valuable option for organizations that need to meet regulatory requirements for cyber protection. Cloud object storage can also be an economical storage option for long-term retention of rarely accessed data. Cloud object storage options include AWS, on or off-prem S3 compatible storage, as well as Azure, to name a few. It goes without saying that every tape moved to an eVault location is marked as eVaulted in our virtual tape database, or VDB for short, and any mount request for a tape located at an eVault location will have VTFM automatically retrieve that tape to the main VTFM library. The eVault process flows as follows. An eVault request can be initiated in several ways: by the user from an ISPF panel, by tape management, or by internal VTFM functions, including those dealing with tape pool space management and tape pool attribute of eVault upon unload. The eVault manager receives the request for an eVault, reads the virtual tape database, and ensures that the location of the tape is local so it can be eVaulted. The eVault manager then references the virtual tape container dataset on the disk pool that holds the tape, makes sure that it's accessible, and then continues to process the tape. The virtual tape container is then moved to the appropriate eVault, be it cloud object storage, an FTP server, or a remote ZOS that runs VTFM. As with every VTFM change to the status of a tape, an update is then issued to the virtual tape database, or VDB, specifying the new eVault status. And because we protect the VDB, a sync is then issued against the VDB with the creation of a journal record. This is the eVault processing flow. As previously mentioned, Cloud Data Storage, or CDS, is based on the evolution of VTFM's eVault technology to include any ZOS dataset. Otherwise, this has nothing to do with virtual tapes. CDS is VTFM's way of storing and restoring from the cloud any type of ZOS dataset. Every ZOS dataset copied via CDS contains embedded metadata that allows the restore process to restore the file directly to ZOS in a readable format. Optionally, VTFM can be instructed to strip out the metadata, creating a flat binary file that contains only the user data. Any user with knowledge of the structure of the dataset can then read it directly in the cloud from a non-ZOS application. It's important to note that once a file is stripped of its ZOS metadata, it cannot be restored back to ZOS. This option's sole purpose is to provide data access to non-ZOS programs. For example, to assist with application migration from ZOS to the open environment. So, when you copy datasets using CDS, you have two options. Copy the dataset with its metadata so it can be read back into ZOS if needed, or copy without metadata for processing by open system applications. Datasets copied via CDS can have an expiration date, and VTFM can expire these datasets on the cloud without having to retrieve them. Up to 999 versions of the same dataset may be stored in the cloud, and you can selectively manage and recall every one of these versions as needed. You can use an ISPF dialog or batch job to request the creation of a dataset in the cloud, or to manage existing copies of the datasets in CDS, restoring, deleting, and expiring them as needed. Another very important aspect of the management of eVaulted virtual tapes or datasets copied using CDS is the ability to restore or rebuild the virtual tape database by scanning the eVault or CDS storage location. So the cloud dataset creation and retrieval process flows as follows. A request is made to copy a dataset to the cloud or to retrieve a CDS from the cloud to local DASD. The request goes to the VTFM server for backend processing. Once the request is approved, VTFM initiates an STC of type CDS service address space to handle the actual CDS operation asynchronously. Next, VTFM reads the user dataset into the service address space, and in the case of a copy to cloud request, writes it out to the cloud. VTFM then updates the VDB with a CDS entry for that dataset, and of course we always update the journal. A sync is issued by the VTFM STC server, and a journal record is created for VDB forward recovery purposes. And this is the process flow for a CDS going to the cloud or back from the cloud to DASD. Now let's discuss how VTFM handles storage and recovery. We start with a ZOS system with VTFM installed. VTFM writes to local DASD or to cloud object storage, off or on-prem, your choice. It may be advantageous to utilize a mix of on and off-prem storage with some tapes stored on FICON attached DASD and local cloud object storage, and other tapes stored on cloud storage as a service. Again, your choice. The same applies to the use of CDS where ZOS datasets are directly stored in on or off-prem cloud object storage. The user sets this up in the PARM lib that manages VTFM. Of course, all the heavy lifting, the main processing cycle consumption, is done using zip cycles. Beyond the day-to-day tape workload, tapes are routinely eVaulted off-site, maybe via eVault Type 4 to a DRZOS site with VTFM installed. The tapes may also be eVaulted to an off-site FTP server or to off-prem cloud object storage. As usual, any change to a tape status is accompanied by an update to the VDB and its journal. But sometimes bad things happen. Your system may experience a disaster. The disaster might even impact your disaster recovery site. As long as your off-site eVaults are intact, you can always use them to fully recover. And this is how you can recover operations with VTFM NewGen, even in cases where your disaster recovery site is impacted. First, you need to make sure your off-site disaster recovery eVault is accessible, be it in the cloud or an FTP server. With the storage site now available, you need to install a ZOS with VTFM at your new recovery site. You just reinstall everything. You now have a VTFM installation with an empty virtual tape database. No worries, the VDB can be repopulated by reading the eVault storage site, in this case Cloud Object Storage, and rebuilding the VDB like so. Now that the VDB has been populated by scanning the eVault site, VTFM can use the VDB to start restoring your data from the tapes at that storage location. By the way, the same can be done if your disaster recovery eVault site is an FTP server. The very same thing. You recover the VDB and then you recover your tapes from the FTP site. During this process, of course, every change in the status of a file or a tape is accompanied by an update to the VDB. At the conclusion of this process, you'll have a fully recovered system at your recovery site. And this is how you do a complete recovery using VTFM. Now let's consider a use case, a customer story. The customer is a large international bank with over 10,000 MSU on the floor. They started to experience issues with their VTS tapes. Specifically, they started getting data checks on their physical tapes during DR site recovery tests. This was seen as a major issue as they had a relatively small cache with most of their tape data residing on 3592 cartridges. There was pressure from regulators and from the business to ensure recovery with zero tape errors. At the same time, they wished to introduce immutable storage to ensure safe recovery in the event of a cyber incident. The projected restore rate using their local cloud service was not as rapid as that of recovering from tapes located on on-prem storage, so they decided to implement both backup target types. Tape backup to on-prem cloud object storage with replication of the tapes to the disaster recovery site for fast recovery from the local tapes, and duplicate backup to tape on immutable off-prem cloud object storage for cyber resilience. We suggested the following architecture and it was implemented. Their main ZOS site with VTFM NewGen and their DR ZOS site with VTFM. Both sites with Vicon connected DASD storage for regular ZOS processing, and both sites with local S3 cloud object storage for the virtual tapes. Writing backup tapes via VTFM NewGen to local S3 storage. The S3 storage device's replication function replicates the tapes to the DR site. Once replicated to the DR site, the tapes become local to that site's VTFM. VTFM at the DR site is then positioned to restore from the replicated virtual tapes in the event of a disaster. At the same time, another copy of the tapes is written to off-prem immutable cloud object storage. In the event of a regular restore, they just restore from the replicated tapes on local S3 storage at the disaster recovery site. However, in the event the primary site data is corrupted due, for example, to a cyber incident, then the DASD at the main site contains corrupt data, which means the main site backup tape is no longer good, nor is the replicated tape at the DR site, which means a restore from DR side tape brings up a system with the same corrupt data. In this event, the user falls back on their off-prem immutable tapes on cloud object storage. The clean tapes are recalled from the cloud by VTFM to the existing tape repository on the disaster recovery machine. VTFM then restores clean files from these tapes. Restoring these files creates clean DASD, and that clean DASD eventually allows resumed operations at the disaster recovery site. They then reverse replicate from DR site S3 storage to main site S3 storage, thus creating a clean tape repository at the main site. And restoring datasets from these tapes at the main site creates clean DASD with clean datasets. This is one user's DR approach, a two-pronged strategy that benefits from both the velocity of a restore from on-prem storage in the case of a non-cyber event, and the bulletproof cyber resilience of immutable copies in the cloud in the event of clean on-prem tapes being unavailable at the DR site. So why choose VTFM NewGen? Let's review. VTFM is a software-only solution that consumes mostly zip cycles. You eliminate hardware vendor lock-in with a software-only solution that's hardware vendor independent. No application changes and no JCL changes are needed. VTFM installs and integrates dynamically into your existing workflow through its built-in facilities and dynamic reallocation technology. VTFM offers a unique facility, Parallel Access Tape, or PAT. PAT provides for concurrent read access to the same virtual tape by multiple users or jobs. Multiple files may be read concurrently from the same virtual tape using as many concurrent jobs as you want. Take, for example, stacked tapes generated by DB2 backups. You may have thousands of tables in the same tape. Now you want to restore them. Using any other solution, these tables will be restored sequentially one after the other. But with PAT, you can run 100 jobs concurrently, each restoring a table from a different location on the same tape. In doing so, you dramatically reduce the time it takes to restore those tables. No other virtual tape solution can deliver this. Only Logon VTFM. VTFM makes it easy to retire your expensive VTS hardware. You can move your tapes off the hardware using either a passive or active migration approach. Using the passive approach, new tapes are written to VTFM rather than your VTS via VTFM's dynamic reallocation rules. Taking the active approach, use HSM Recycle and/or your tape copy utility to copy your existing tapes to new VTFM media. With this approach, all virtual tapes in your VTS will eventually be moved to VTFM. With VTFM, you have your choice of virtual tape storage targets, including the cloud. Moving your tapes from VTS hardware to cloud object storage delivers a tremendous reduction in total cost of operation. You choose where you want to store your tapes. Local FICON connected DASD, on-prem S3 compatible storage, off-prem cloud storage, or a strategic mix. The storage target for each tape can be based on access frequency, performance, cost and security considerations, and you can implement your analysis for automatic execution through policies. VTFM offers multi-tier protection of your virtual tapes through several eVault options. Type 3 directs your tapes to any FTP server around the world. Type 4 moves those virtual tapes to a remote site running ZOS and VTFM, where they are readily available for mounting in the event of a disaster. Type 6 places them in the cloud object storage anywhere in the world from where they can be recalled in the event of a disaster. In all cases, VTFM's virtual database can be rebuilt, if needed, directly from the contents of your eVault. In the same solution, you also get the ability to copy any ZOS dataset to the cloud object storage with multi-version capability and expiration of old versions handled on the cloud. You get faster virtual I/O completion. VTFM uses asynchronous I/O for its in-memory virtual disk structure, issuing one physical I/O that may chain multiple CCWs. So VTFM can write multiple tracks, each containing multiple user blocks, instead of just one user block for each I/O. This dramatically reduces overall time spent in I/O during the batch window. Most importantly, the recovery time will be much faster because we do the same in reverse on a virtual tape read. And everything VTFM does is done through standard ZOS facilities. Finally, both virtual tape and CDS capabilities come as part of a single solution. Well, that's the presentation. I hope that was informative. I do have a few questions from the audience queued up here, and I'd like to thank you for your patience. The first question, what SMS changes would I need to make to switch allocation of our tape devices to VTFM? It's a good question. You hit an important point here. Just 3 SMS changes are needed: a store class, store group, and 1 modification to the store group ACS routine. That's it. And interestingly, most sites don't believe us and start making unneeded changes to SMS, and then those need to be backed out. It gets to be a little bit of a mess. So installing VTFM is not that complicated. We always advise that new users read the manual before installing. It's all there step by step. Okay, here's another. Does VTFM New Gen require a Linux server? Some other products do, but the answer for VTFM is no. VTFM runs entirely as a ZOS application. We do direct user requests to Cloud Object Storage and to FTP servers, but these services are external to our code. All right, another, do I need to change my production workload to use VTFM? And that's a good one. No, there's no need to change tape jobs when moving to VTFM. You just control the dynamic reallocation of your old tape devices to new VTFM tape devices by defining a policy. This one just came in, and thank you for that. Can I define different storage classes for different tape workloads? We want to move infrequently accessed data to the cloud, but we want to keep copies of our critical tapes locally. And the answer to that is yes. You just do this by defining different VTFM New Gen internal tape pools, and each one would have a storage class that includes the desired attributes such as storage residency, Valseer range, availability of scratch tapes, and so on. You then use a tape pool rule policy that directs requests for new virtual tapes to the correct tape pool. That's all there is to it. Okay, I don't have any other questions in my dash. Are there any fresh questions from the audience? I'll give it a couple of seconds. And that seems to be it. And again, I want to thank you very much for your time. I hope we hear from you. We always enjoy working with customers, addressing their challenges, and please feel free to reach out to us at ask@log-on.com, and I hope you enjoy the rest of your day. Thank you.
Thank you, Mark, for your very informative presentation today. And thank you all for attending today's Enterprise Tech Journal hosted webinar. Within the next week, I will be sending you the list of questions asked and the answers to them. Please be sure to check your spam folder as well. If you have any questions concerning today's presentation, please send an email to ask@logon.com. You can also visit their website at www.logon.com. Bye for now, and we hope to see you in our next webinar.